to Physics 122. I'd like to begin by reviewing some of the key facts about forces, which will set us up to continue from where you left off in 121. Okay, so first of all, forces always have a few properties. So every force has a type, an on, and a by. Okay, and what I mean by a type is that it is, a gravitational force or a normal force or some other type like that. And what I mean by an on and a by is that every force has to be exerted on some object, and every force has to be exerted by some object. So, for example, if we consider something like a weight force is a gravitational type. It is exerted on an object, whatever object has that weight. And it is exerted by the Earth. So if I wanted to write that as a shorthand, I would write that as a gravitational force on the object by the Earth. That's the notation I like. Some people like to use W for weight. I think just grammatically that's a little more confusing, but gravitational force on the object by the Earth. Another example is I could just push on an object. I could take a book, for instance, and push it across the table. So an ordinary push is what we call a normal force. And that is again on an object, this time by, let's say, my hand. So I would label that one normal force on the object by the hand. Okay. Sometimes people get a little confused about normal forces and think that they're associated with, gravity or something like that. But remember, a normal force is just an ordinary pushing force. There are a variety of different types of forces that you have seen up to this point. So I mentioned gravitational forces and normal forces. So there's also tension is one that comes up a lot in 121. Friction is another big one. And if you go through 121, probably 95% of the forces are either gravitational, normal, tension, or friction. There are very few other kinds that show up in that context. However, there are some others. So some that you would see from time to time in 121 were a magnetic force, maybe. Or you might see a buoyant force. That's the force that causes, say, a helium balloon to want to rise upward. Another one you might see is lift for airplane, for instance. And there are a bunch of others. So those were all different ones that you might have seen in one or two problems in 121. So in 122, we're going to be focusing on electric forces, magnetic, and we're going to start out with one chapter on gravity. Okay, so an electric force is what you would think of as static electricity. So if you rub a balloon on your hair and you notice that then your hair is attracted to the balloon, that's an electric force. We're also going to spend a lot of time on magnetic forces. And like I said, we're doing one chapter on gravity. Okay, so there are some other properties that forces have. So in addition to having a type, an on, and a by, we had several laws that governed how forces operate. So one of those was Newton's third law. which I like to abbreviate N3L. And what Newton's third law tells us is that if there's some force with a particular type that is on object A by object B, then there always, in every circumstance, has to be another force that is the opposite direction and the same type, and the on and by are switched. Okay, so to look at some of the examples that I mentioned specifically so far, if there's a gravitational force on an object by the Earth, there has to be an equal gravitational force on the Earth by that object. If the object's pulled down, the Earth is pulled up. If I push on a book with my hand, then the book pushes back on my hand with a normal force of the same magnitude. So it's always the same type. So be careful that you don't think of Newton's third law as, for instance, saying that a gravitational force is always balanced by a normal force. It isn't. Lots of times gravitational forces are not balanced by any force, and that's why objects fall. And then the other of Newton's laws that is, sort of very useful in 121 is Newton's second law. Or N2L. And what that tells us is that if we take the net force that on some object, and so we add up all those forces, that's equal to the mass of the object times the acceleration of that object. Okay, so the acceleration of an object is always in the same direction as its net force. And, in some ways you can think of this as defining mass, which is kind of interesting. We would call this the inertial mass, is the ratio between the net force and the acceleration of an object. So those are some of the key ideas of how forces work. These are true for all forces, and as we continue on to study gravitational forces in more detail, and also electric and magnetic forces, you should always be keeping these properties in mind.